If you have some rudimentary carpentry and plumbing skills, you may be interested in building your own solar hot water system. High-tech photovoltaic systems have come a long way since the advent of space exploration, but the initial investment of a PV installation may still be unacceptable to many homeowners looking for a payback period of less than 7 years. The good news is a well-planned DIY solar hot water system could pay for itself in less than 2 years for an initial investment of $800. Solar hot water systems do 4 things. They collect sunlight heat, they store sunlight heat, they preheat water for domestic hot water systems, and they automate the process of collecting solar heat. Solar hot water systems are considered active if pumps are used to transfer heat. If no mechanical devices are used, they are considered passive. A simple passive solar hot water system is a batch heater. It uses the same tank to collect heat that it uses to store heat. The batch heater is best suited for sunny areas where freezing is not a problem. Unfortunately, the efficiency of the batch heater is low, since the area of heat collection is the same as the area of heat storage, and much of the heat is lost through the glazing material. Thermo-siphoning batch heaters are more efficient than simple batch heaters because the collector portion of the unit is isolated from the storage chamber. Unfortunately, the storage tank size of thermo-siphoning batch heaters is small. Also, the sunlight intensity must be great to get a significant heat exchange in a thermo-siphoning system. Flat plate collectors are lighter than batch heaters, and they are easier to mount on a roof. Heated water from flat plate collectors is stored in drums far from the collectors, so the storage vault size can be large. Commercial collectors use parallel flow tubes called risers. These risers are bonded to headers and soldered to a sheet of copper. This makes commercial collectors heavy and expensive. Homemade collectors often use aluminum absorber plates to save money on materials. Evacuated tube collectors do not lose heat through glazing materials like flat plate collectors. They use copper tubes filled with acetone to transfer heat, sealed inside evacuated glass tubes, so very little heat is lost. Boiling acetone accumulates inside the top cap of the heat exchange tube, where it condenses and releases heat to the collector fluid. Evacuated tubes can produce very high temperatures, but the area for heat exchange at the top cap is so small that the amount of heat collected is small compared to the surface area of the tubes. Other problems to consider have to do with leaks that develop at the junction where the glass tube slides into the heat exchange chamber. Also, if you live in snowbelt areas, you may have a problem with snow accumulation, since evacuated tubes are so well insulated. Okay, we've talked about some of the most common collectors, and we've even mentioned a few solar hot water systems when we talked about the batch heaters. Batch heaters are by far the most simple. They do not require pumps because they are connected directly to the cold water supply. Unfortunately, they do lose a lot of heat through the hot batch heater tank. Next, we will discuss active solar hot water systems. But before we do, we should talk about the advantages of a Serpentine flat plate collector. This homemade Serpentine collector has one long 3/8 inch flow tube. At first, it may seem difficult to bend, but with the proper jig, it's fairly easy. The advantages of a Serpentine tube have to do with the absence of headers and risers, as well as the absence of 4 dozen solder connections. This lessens the chance of leaks, simplifies construction, and saves money on materials. Now that we know 3 active solar collectors, we can talk about 3 active solar hot water systems. They are the closed loop, the drain down, and the drain back systems. Closed loop systems normally circulate a mix of glycol and water. There is no height restrictions on closed loop systems, but They do require an expansion tank, a pressure relief valve, a check valve, a fill pump, and a fill spigot. Evacuated tube collectors must use closed-loop systems to protect the collector from sudden temperature changes. Open-loop systems are preferred by most plumbers. They do not require antifreeze because water is removed from the collectors when they get cold. Drain-down systems work like closed-loop systems with an emergency drain valve that's activated when freezing temperatures are sensed. Unfortunately, the drain-down valve does not always open when it should, so the drain-down system is no longer popular. Drain-back systems are different than drain-down systems. Drain-back systems drain water back from the collector when the pump is off. This simplifies the method of removing water from the collector whenever the collector is colder than the storage tank. So, the three most common solar hot water systems are the closed loop, the drain down, and the drain back. Are we done? Almost. We still need to automate the solar heat collection process. Sunlight is an intermittent resource, but people need hot water on demand. A differential controller makes a net heat gain possible. It simply turns on a pump when the collector temperature is greater than the storage temperature. When the collector cools down, the pump turns off, and collector water drains back into the storage tank. All the user has to do is strike a balance between heat collection and energy consumption. This is done with the help of a heat available indicator. Thank you for your time. If you need more information about homemade solar hot water systems, visit JC Solar Homes.